Today we will talk about openSUSE as an upstream of SUSE Linux Enterprise. So since this is the business-friendly session, when we talk about SUSE Linux Enterprise, we talk about multiple things actually. We have the server, we have virtualization, we have enterprise desktop, and lots of other things, which we want to mention all of those. And what we are interested in is the openSUSE project itself as an upstream. So when we look at the openSUSE project, we see it's more than a distribution actually. It has marketing activities, it has a distribution team itself, it has sub-projects like education, medical, and other things like Open Build Service, the openSUSE board, and others. Actually, openSUSE is a very big community. It's about an ecosystem. When we look at the distribution, we see that it has more than 5,000 packages. And it comes in different flavors, like there is an ARM port, there is a work in progress PPC port, and of course x86 and 64 bits. And when we talk about the distribution, we have the bleeding edge, so-called factory, which drives the next release, and it's most of the times is not really stable, but mostly usable. And we have the usual releases. openSUSE 12.2 is just released, possibly, you know. Stable releases take 2 releases of lifetime and sometimes overlap, 2 months. So it's 18-month cycle of updates. And if you want something changed every day, updates every day to newer stuff, you got a so-called rolling release, which is openSUSE Tumbleweed. It gets the latest release of software from multiple projects on Open Build Service. So next topic is SUSE Linux Enterprise versus openSUSE. What is different? What is similar? SUSE Linux Enterprise is, the name itself says, it's enterprise-centric. It has enterprise support, 10 or more years of lifetime, which is a lot more than openSUSE can offer. It has corporate maintenance and other stuff like enterprise hardening and indemnification, which is important for patent stuff in the corporate world. When we look at SUSE's upstream, there are multiple projects actually. GNOME is, for example, is an upstream of SUSE. For example, in SUSE Linux Enterprise, you have GNOME 2, which doesn't exist on openSUSE now. So GNOME is directly in an upstream, openSUSE is the base of SUSE Linux Enterprise and it's upstream. So in the current situation, upstream makes decisions, which is actually independence of the downstream. In this case, openSUSE takes its own decisions, not based on SUSE Linux Enterprise. But upstream always take care of downstream when taking decisions. SUSE Linux Enterprise is not actually a clone of openSUSE. It is different. It has a different installation method. It has different installation defaults like separate home. It has different package patterns. For example, minimal system enterprise is different than what we have in openSUSE. And most importantly, it supports lots of different architectures like IBM Systemctl, Power, Itanium, which openSUSE does not support at all. We do support ARM and Power, but it's work in progress for openSUSE and is not stable. When we look at how this interaction happens, we see that openSUSE does a stable release like 11.1, then this code goes to SLE 11 at some point, and after some stabilization, the SLE 11 is released as general availability. And after some time, the bug fixes in SLE 11 gets into openSUSE itself. So we released 11.2 in openSUSE. This goes on with Service Pack 1, Service Pack 2, and for example, SLE 12 will be based on openSUSE 12.2, possibly. It might be 12.12, that's why I said possibly. So this is a win-win situation for openSUSE. For openSUSE, we got bug fixes from SLE, enterprise testing, development. Actually, LibreOffice, for example, is developed by the SLE team, and it's committed to openSUSE 3.2. Yast and Linux kernel is also developed by the SLE stuff. SUSE also funds the development of openSUSE and, of course, gives us source packages for many packages. For SUSE Linux Enterprise, this means you got a stable distro basis, which is openSUSE, which is tested. You have more than 5,000 available packages. If you need some package, you can take from openSUSE and build upon it. What SUSE also gets is relationship with upstream projects. When people use openSUSE, they get familiar with the SUSE brand. So this is important for SUSE. So let's see how openSUSE builds the whole distribution, builds this whole ecosystem. The tool we use is the Open Build service. Think of it as a build farm. It's a machine which produces packages. It's free, and it has more than 30,000 users currently. It's actually more. It supports 8 distributions. This includes Fedora, Red Hat Linux Enterprise, or CentOS, or Arch. You can build for 5 different architectures. How we do this is easy, actually. It runs virtual machines with support for Debian, RPM, Targas, even Windows executables, actually. LibreOffice for Windows is built on OBS with free software, which is something, actually. Open Build service is actually very popular in corporate world too. For example, it's used by our partner B1 Systems, Intel, Dell, VLC project, INRIA. Dell and Intel, they have their own OBSs, which is a little bit modified. Since it's open source, you can take it and modify it. We have some screenshots of OBS here. This is the web interface we see here. So this is a home project for Sasha Pelichke. You see it builds for multiple distributions like CentOS, Fedora 12, Fedora 13, Mandriva, and Red Hat Linux Enterprise 2, all on the same project. Also, you see that you can see your current requests on top, so you can see who's tried to submit something to your project, so you can accept or reject that, or wait for later to take action on it. This is the web interface for actually changing the package spec file. So in your browser, you can update the package, add new stuff, change packaging rules, all in your browser. You don't need the command line. And actually, you can do the same in command line, but mostly we prefer web interface because it's easier. And we have another view of web interface. This is, so you change something, you commit it to your project, but you branch from some other project. In this case, it branched from Devel library C++. So you want to commit your changes to the upstream so it can go into the factory in the end and go to the users. So you add a description. You can click remove local package if request is accepted. So if you click this, your package will be removed when your request is accepted. So this is a way to keep it clean if you don't want to develop it further here. What is the request looks like is this. So you see the date, you see who submitted it, you see where it is going, the target, who requested it, what kind of request is this? It might be a delete request or a submit request, so you want to delete packages too. And actions, you can see, if you click the I, it will show you that it failed to build or it succeeded to build. If you click the other icon, you can see the build log. So, Open Build service is open source software and can be deployed to your instances, which is actually done by some companies, as I told you. It is also used for building SUSE Linux Enterprise, and it's the same code stream used internally. same as openSUSE build service. It delivers additional packages which might not be in the distro, but user might need it. For example, application geography repository on OBS is really huge. It contains all the geographical applications that's not in openSUSE. It has a whole own community in itself, just on openSUSE build service. If you want commercial support, it's available via partners like B1 Systems, and more information is available on openbuildservice.org. The next product we'll talk about is OpenQA. So, QA is really important part of a distribution. You want your code to be tested. You want to make sure it installs, it updates, it configures correctly, and you cannot do this manually. You can actually, but you will fail because there are multiple configurations to test and multiple cases you have to test for. So, OpenQA is our solution for this. It's a fully automated testing. So it does installs new stuffs, upgrades from existing installations. It does daily regression testing. So you see if you commit something, sorry. So if you commit something and it broke some stuff, you will see the next day. You can test applications. You can also do benchmarking. So it gives you a clear test results with video. So you can click the video and see the whole installation and configuration or the regression testing. So you don't have to do it. So how it does it? It boots the ISO in a virtual machine, usually it's KVM. It has a predefined input like click this button, click Firefox, open this URL, click enter. It takes the screenshot of the result and it compares the screenshot to the predefined result. So if it's not the same, it says something is wrong. So you have to manually check it. It shows the results in the web interface like this. So on the left, you see the known issues, and the ones that are striked out are fixed problems. This is how we test stuff before releasing release candidates and final software. You can also see the whole test. You see is testing, for example, 11.4 KDE 4.6, or GNOME development repository, or 12.2, or just Btrfs. So it has multiple configurations to test multiple stuff, which will be really hard to do manually. And this is the results overview. So you start with the boot and multiple checks are run. If there is a problem, you see a red line saying you should manually inspect this. So in some cases, there are no errors. For example, if an output of a program changes, like Firefox displays a new home page, it might be a problem. You have to manually check and update the test case. So let's see what technologies from openSUSE goes into SUSE Linux Enterprise. First of all, we have the openSUSE ARM, which is started by a handful of community members after OSC 2011. Most of the people were interested, and they started get work on ARM v7. And these days, they released the first version of ARM v6, which means it runs on Raspberry Pi board now, which is really important milestone. And they will release first version based on 12.2 soon, their first stable release. Another thing is that's important for enterprise is virtualization. So in openSUSE, you got optimizations for laptops. You try to save power. You try to save battery. What affects virtualization is that whatever you do in the laptop case sometimes help with the virtualization workload due to moving out idling code, which helps with virtualization to increase performance of workloads. So what we do for openSUSE in users helps the enterprise in SUSE Linux Enterprise. Another important thing that came from openSUSE was Snapper, the snapshotting file system. Snapper works on top of file systems to provide snapshots. Like, it works best with ButterFS because ButterFS already has some kind of some idea of snapshotting. If you don't run ButterFS, it works on top of LVM team provisioning. It's also integrated into Zipper. So you can do a package update, it takes a snapshot, updates the package, then you can roll back the whole thing. It's also integrated into YAST. Another big thing that went from openSUSE is systemd. As you possibly know, systemd is an init replacement. It has socket and dbus activation, which means that services start on demand and not start by itself manually, automatically, sorry. It has cgroup support to track and control service process. It has compatibility with System5 init scripts, and it comes with a useful tool called Systemctl. So what about systemd integration in openSUSE, what we did? Systemd in openSUSE has in-serve support, check config and sbin service, and the most important is you can call init script, the old init script directly, it will work. So it will just redirect to the systemd version, so your old scripts can work. It supports system-wide ulimit setting, and you can select what to allow, what to start by default and what's not. And if you are providing RPM packages with systemd support, you have systemd macros to help you, which makes it easier to integrate into systemd. Here we see that Systemctl is an action. It's called Systemctl status dbus service. This calls what is the status on dbus. You see that it's active and running. You see it's cgroup. It shows the PID. It shows when it's loaded and other logs related to the service. So this will be about it. If you have questions, feel free. Thanks for listening.